Namaskar. Welcome to the course titled Introduction to Compiler. I, IITBombayX Chakravarti, Assistant Professor at Department of Computer Science Engineering in SRM Institute of Science and Technology, Delhi NCR campus. Here, in this video, I will provide an overview of compiler. After completing this video, the learner will be able to identify few learning objectives. We are identifying three learning objectives. First one is the learner can identify different types of translator. Next one is understanding the different types of or phases of compiler. And final one is an overview of tools for constructing a compiler. Programming languages are notation for describing computations to people and to machines. The world as we know it depends on programming languages because all of the software running on all of the computers was written in some programming language. But before a program can be run, it first must be translated into a form in which it can be executed by a computer. So we start with a translator topic. So introduced with the translator, it's a process where a program written in a source language or high level language converted into a semantically equivalent low level language or a target language or machine understandable form. So for this purpose we need a translator. It detects and reports the error during translations. Translator are two types or more than that, interpreter and compiler. Let's start with the interpreter. It also does the same process of translation from high level language to low level language, but it processes line by line. Translation process is done by line. It reports error once it encounters during the translation process. It means that during translation process, if it identifies an error, it will halt there until unless you remove the error. So here a diagram is represented for this purpose. Source program and the input, they are both input for an interpreter. Translation process, it produces the output. If there is an error message, then it will halt. If you remove it, it provides the output. Next one is compiler. Compiler is also a translator, but its processing is different than the interpreter. It reads the whole source code in one go. If it identifies errors, then it generates the list of errors. So here diagram depicts the source program as an input for a compiler and produces a target program. If there is no error, if there is error, it will generate a list of errors. You have to remove it. Now you can pause this video and answer the question. The question is, list the programming language that uses compiler and interpreter. Think about this question for a minute and write the answer on your copy. Once you have written the complete answer, then you can restart and play this video. I hope you have written the answer. The answer is, for compiler, I hope you are familiar with the C language, Java language and C++ language. So these three is the answer for compiler. For an interpreter, it's a GW basic. I hope you heard the name. And the Java output, that is a bytecode, it is interpreted. So this is the answer for the question. Now we start the next topic, that is compilation process. Compilation process is consisting of analysis and synthesis process. This analysis and synthesis process having the phases of compiler. So first phase is known as analysis phase, where it determines the operation implied by the source program which are recorded in a tree structure. Next phase, it takes the tree structure and translates the operation there into the target program. Now, phases of compiler. There are 6 phases of compiler. First one is lexical analyzer, next one is syntax analyzer, third one is semantic analyzer, fourth one is intermediate code generator, fifth one is code optimizer, sixth one is code generator. All the phases are connected to symbol table manager and error handler. So whenever a symbol is identified, it is registered into the symbol table. Maybe that symbol required in the future by other phases. Now we start with each phases. First phase is lexical analyzer. It's also known as linear scanning. Here the source program is scanned to read the stream of characters, and those characters are grouped into form of sequence called lexemes, which produce a token as an output. So token is a sequence of character that represents a lexical unit. So lexical unit is a lexeme, is an instance of a token. That means it's a group of characters, and this group of characters forms a lexeme. It must be matched with some pattern. So pattern is nothing but describe the rule that the lexeme of a token takes. So at the end, lexical analyzer takes the input as a stream of character and produces the output as a token. Next phase is syntax analysis. In syntax analysis phase, it converts the token produced by the lexical analyzer into a tree-like representation called parse tree. It is also known as parsing. Third phase, semantic analysis. It is the third phase of a compiler. It checks for the semantic consistency, performs the type checking. Type information is gathered here and stored in the symbol table or in a syntax tree. There's 3 phases consisting of analysis phase, and it writes the information in the symbol table. Next 3 phases relate to synthesis phase, and out of that, first phase is intermediate code generator. Intermediate code generation produces intermediate representation of the source program, which are the following forms: postfix notation, 3 address code, and a syntax tree. Most important properties of intermediate code is it should be easy to produce and it should be easy to translate into target program. Now you can pause the video and write an answer for the question. What is an intermediate code for C language and for Java language? Think about this question for a minute and write the answer on your copy. Once you have written the complete answer, then you can restart and play this video. I hope you written the answer. So in case of C language, the intermediate code is .obj file, and for Java language, it's a bytecode, that is .class file. Now, the next phase is code optimization. Code optimization phase gets the intermediate code as an input and produces optimized intermediate code as output. It results in faster running machine code. It can be done by reducing the number of lines of code for a program. This phase reduces the redundant code and attempts to improve intermediate code so that it can generate faster running machine code. And the final phase is code generation. Code generation is the final phase where it gets input from code optimization and produces a target code or object code as a result. Now, again you pause the video and give the answer for a question. What is a symbol table? Think about the question for a minute and write answer to your copy. Once you have written the complete answer, then you can restart and play this video. I hope you've written the answer. Symbol table is used to store all the information about identifier used in the program. We have a symbol table management. Its main works is to identify identifier and other symbols that is used in the source code. It will store the information in the symbol table, and there are different types of attributes in the symbol table: the storage allocation type, scope, arguments. The final part of the phases of compiler is error handler. Error handler is the most important. It is associated with all the phases. It helps to rectify the errors or informing it to the user. So most common examples in few phases, like lexical phase. Here misspelling occurs. In syntax phase, it violates the structure rules. That is example like unbalanced parentheses, missing punctuation operators, and undeclared variables. Consider semantic phase. That means no meaning of operation. Suppose an array name and procedure name is adding up. Truncation of results or unreachable code. In code optimization phase, error occurs when the result is affected by the optimization. And in code generation, it shows errors when code is missing. So all about the phase of compiler. Now we see an example for a translation of a statement. Suppose consider position equals to initial plus rate star 60. So it's a high level language code. Now in each of these phase, gets an input and produces an output. So first one is an input, the high level language. The lexical interpreter generate tokens, ID1, ID2, ID3. These are the tokens generated on behalf of the variable used in the high level language. After that, a parser is generated for a syntax analyzer. That gives the meaning to it. Check whether it's a violate or not violate the rule. Next, intermediate code. So your initial statement is broken down into a number of small codes. Then code optimizer. After the intermediate code generator, the output is a for statement. After code optimization, only two statements are reflected. After that, over these two statements, the machine code will generate the assembly language code. Now, final topic is compiler construction tools. Software development tools are available to implement one or more compiler phases. They are commonly used compiler construction tools. Started with the parser generator. It takes grammatical description of a programming language and produces syntax analyzer. Scanner generator generates lexical analyzer from a regular expression description of the tokens of a language. SGT engines, it produces collection of routines that walk a past and generate interpreted code. Next one is automatic code generator. It takes a collection of rules that define the translation of each operation of the intermediate language into machine language for a target machine. Data flow analysis engine. It gathers the information, that is the values transmitted from one part of a program to each of the other parts. Data flow analysis is the key part of the code optimization. Finally, the compiler construction toolkits. It provides an integrated set of routines for various phases of compiler. Compiler construction toolkit provides an integrated set of routines for construction of phases of a compiler. Finally, if you want to know more about the compiler, then you can refer these books. They are commonly known as Dragon Book. Currently, the edition in the market available is with the 4 author name Aho, Shetty, Ullman and Nam. The previous version of this book, same book with the 3 authors, Aho, Shetty and Ullman. So you can buy any of the books or refer any of the books for further knowledge in a compiler. Now, there is a practice activity after this video to check whether you understood the concept of learning dialogues or not. Make sure that you do this activity. It will help you to recall and understand the concepts. Thank you.